finish up that last sentence that you're reading. Close your books and track me in the next 10. Books closed, track me in 5, 4, 3, 2, 1. Books closed, track me. Janai closed her book. Daniel's tracking me. Joshua, welcome back. Missed you, buddy. Yesterday we talked about how there are two messages, two things that I was thinking about coming off of the mountain. One, the message of not done yet. Many times as we climbed up, we thought, we're there. This view is beautiful, but we still have to push through. We're not done yet. The second thing, Joshua, I want to name because you actually inspired this thought. When we got to the top, you remember me saying it? Josh said, this is it. I thought this would be better. That reminded me of what I said the first day of math. The beauty is not in the solution. The beauty is not in top. It's in the journey. It's not the destination. It's the journey. We are going to continue our journey today with lesson 6 of our unit. I had an interesting conversation yesterday with a middle school principal out in California about how different we are as a school when we approach fractions. And I was telling him how proud I was of how you see and visualize fractions in a way that I never did when I was your age. So I'm excited to see how you look at unit fractions as the divisor today and see if you can come up with a conjecture based on when you already know what to do to divide fractions. 20 seconds to get classwork for 2 weeks. Ready? Set. Go. 19, 18, 17, 16. Moving urgently to get through classwork today. Sarah's already got her name right at the top of the page. Five minutes on the clock. See if you can solve all 3 problems and then work on your explanation. First 30 seconds, you should have a solution for that first problem. Good. Taylor's almost done writing down her heading. Jeremiah's already got a model to represent that first problem. Coming around in 10 to check your annotations, see how far you that first problem. Daniel's on his third problem. Alright, got all 3 done. Moving on to his explanation in the next 30 seconds. Aaron Merrick for your urgency. Really appreciate the hustle. Get back to your interview. 2.5 minutes left. Byron's completed all 3 problems and his explanation. Got 2 minutes to read. Finish up what you're writing, track the board in the next 5, 4, 3, 2, 1. Pause, pencil, track the board. Jeremiah, pause his pencil, Nia is tracking the board. Before I show you 2 pieces of awesome work, Justin, yours is included. Quick annotation, because some of us might be in the room and we don't know what unit fractions are. What are unit fractions? Can you remind the person sitting next to you in the next 20 seconds? Turn. Javier's turning. Edwin's turning. What are unit fractions? Go.
Unit fractions
Five, 4, 3, 2, 1. What are unit fractions? Jordan. Michaela's turning to track Jordan. Vanessa's turning to track Jordan. Aiden Demerick, track Jordan.
Unit fraction is like one is that denominator, and then you one that denominator, and equals the front, and how many of those
You said, did you say 1 is the denominator? 1 is the numerator. So let's go ahead and make that annotation. Fractions when 1 is the numerator. So when we talk about unit fractions, 3, 4, we're talking about 1 being in the numerator. So that's a unit fraction. That's a unit fraction. 1/4, 1/2. Great. 2 pieces of work. 2 snaps for Justin on 2, 1, 2. Take 10 seconds to look carefully at his work. 5, 4, 3, 2, 1. This is Christian's work. 2 snaps for Christian on 2, 1, 2. What's similar about their work what's different about their work? Here's Christian, here's Justin. Christian, Justin. What's similar? What's different? With the person sitting next to you, Kurt? Five, 4, 3, 2, 1. Everton. Denise, talk. Turn the track. Kiara's turning the track.
The difference between Justin's and Christian's work is that Christian uses diagram and Justin did.
Couldn't hear that last part. Can you read it?
They use the diagram.
Introduction, sorry, I didn't hear it all what you said. Can you revoice what he said if you heard it in? Go ahead, loud and proud. We just talked about that in town hall.
He said that Justin didn't use a tape diagram.
Oh, he didn't use a tape diagram. Yeah, he used a different type of division model. What's the same? I heard you talk about what's different. What's the same? Love the amount of enthusiasm and engagement that I'm seeing. Your hands, you're speaking to me. Jeremiah, turn track here. Emma's turning the track. Orlando's turning the track.
Something I noticed is that both of them made the dividend, they put it into a whole number, and then they multiplied the divisor and the dividend, which got them 8.
So generalize with me, is there a more efficient strategy than using the model to solve when we're dividing by a unit fraction? What could we do to make things faster as problem solvers? 30 seconds. Dustin's turning. Caleb's turning. Chair. And 5, 4, 3, 2, 1. How can we apply a more efficient strategy when dividing fractions by a unit fraction? What do you think? Hands down. Track keeper, who's in the back? Justin's turning the track. Jorge's turning the track.
I think that it would be a better efficient method to use division will be if the denominators were the same, it would have been like easier or like more efficient for the numerators to be able to divide.
Is that what happened here? Did we make common denominators here? Yes or no? No. What was the strategy that both of these guys used that was more efficient? Emma, turn track, Emma. Michaela's turning to track, Edward's turning to track.
The strategy that we used here to make it more efficient was that we took the denominator of the unit fraction and then we multiplied it by the whole number, and so that made it more efficient and faster and easier.
Beautiful. Thank you, Emma. Absolutely merit for your strong voice. Turn and look at the bottom of the next page which says conjecture. We're going to write that down. Update along with me. Today we are proposing that we can multiply the dividend which in this case, tell me about the dividend. They were all what? Jeremiah?
The dividend was the whole number.
That's right, the dividend, I'm going to write down in parentheses, whole number by the denominator, and I'm going to say, just as you said, it's the denominator of the unit fraction. Okay, let's finish in her update. Edwin's done updating by writing his conjecture just as he saw it on the board. So let's test that out, Kelly. You should be updating with an annotation in the next 10, 9, 8, 7, 6. The problem says evaluate the expression 3 divided by 1/6. What did you annotate? Quick, Devin.
I'll put 3 as the whole number.
3 whole numbers. What's 1/6? Christian.
Unit fraction and the divisor.
Unit fraction. It's also our divisor. Let's not forget that. This is our divisor. This is our dividend. According to our conjecture, what should be true? 3 divided by 6 should be the same as what expression? With the person sitting next to you, 5 seconds. Start checking. 5. 1. 3 divided by 1/6 is the same as what? Multiplication expression. Mia.
3 divided by 1/6 is equal to 3 times 6.
3 times 6. And if you know your multiplication tables, you should, but now, 3 times 6 is?
18.
18, absolutely. Check your reactions. Good, 18. How can I check to make sure that that's true? 1, 2, 3, 4. Only 4 people are going to check for reasonableness. That's disastrous. Always want to make sure we check our accuracy so that we can prove what we said is true. Evan, all the way in the back. Turn track cam. How can we check our work?
So how we can check our
Hold on, Kevin. Make sure you have 100%. That's why I always give you the moment, and I'll say, Christian is tracking, and I am tracking.
So, how we can check our work is by dividing, because in 5th grade they show us that when you're checking your work, you always use the opposite.
Oh, I know what you're saying. So Kevin, like you're saying 18 divided by 6 is going to be 3. But we want to go back and use that unit fraction to check. So what here's what I'm going to do. I'm going to split my page. That's my solution, right? Here's my check step. Write your check step, underline it. Since we're talking about 1/6 as our divisor and 3 whole numbers, I'm going to draw a cake diagram to represent the 3. 1, 2, 3, 4, 5, 6. That's 1 whole. Continue drawing so that you can see there's 3 whole numbers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Annotate. This is 3. That's your whole number. Annotate. Draw a circle around just 1. And Jordan, we're going to label that what? Jorge? That's a 1/6. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 all together. Silently read the last problem on this page on your own while I read it out loud. Chris has 2 3/8 pizzas left over that he wants to give to a group of his friends that are coming over for dinner. He wants to give each friend 1/8 of a pizza. How many friends can he feed if they eat all of the pizza? What did you annotate? What's the expression that represents this problem? Ready to share? 20 seconds. Turn. Daniel's turning. Good eye. Excited to share. Turn. Share.
I agree with you, and I put it as like
10. 5, 4, 3, 2, 1. What did you annotate? Jonathan, he's in the back. Turn to track him. Michaela's turning to track. Everton's turning to track.
What I annotated was at the beginning 2 and 3/8 pizza left over, and I put that as the dividend, and then I put each friend 1 and 1/8 of a pizza as the divisor and the unit fraction.
Indeed. What's the expression that represents this problem, Jorge? Jorge, you're being disengaged. Here's why it's disengagement. He just gave you the total. He just gave you the dividend. He just gave you the divisor. He gave you the amount in each. Put that together. What's the expression that represents this problem? Still, yeah. Still? Javier. Loud and proud. Imani's turning to track. Orlando's turning to track. I'm coming back to you, Jorge. Indeed, did you hear that, Jorge? What's the expression? 2 and 3/8. Write it down if you don't have it. And when the expression to represent this problem, Aiden, 2 and 3/8 divided by 1/8. Devin, I heard you say something really smart in your turn and talk. Can we apply the conjecture to this problem? Hold on a second. Let just everyone sit and let that question sink.
I said we
Hold
can't.
on a second. Let me. Everyone's still waiting to hear me repeat the question because Aiden, I know he already forgot the question. Can we apply the conjecture to this expression? Track Devin. Byron's turning to track. Garrett's turning to track.
So I said we can't apply the conjecture because
You said we can or cannot?
we can't.
We can't. Why not?
Because our dividend is not a whole number. It's it has a whole number and a fraction next to it, and so we can't apply the conjecture because it's not a whole number.
We can still divide. We're not going to do that, but we want to apply the conjecture. So therefore, turn the page. There are going to be some practice problems that we cannot apply the conjecture to, and that's okay. Just write the expression as you see it, and you're only solving the ones that we can apply the conjecture to. Partner practice begins. Now you have 5 minutes. See if you can finish 1, 2, 3 questions for partner practice. Ready? Go.
Two multiplied by 5 because if we use the whole number, we have to multiply it by 6. Let's go. I think I you don't add the denominator to the add. You just divide the
By now, you should be moving on to question number 2 because letter B and C are not applicable to our conjecture for today.